In the last video, we talked about how to design a car class. So we talked about class attributes like top speed, odometer, headlights, and MPG, and we said that these are the same initially when we build a car from this class. We also talked about instance attributes like color and interior, and we said that right off the bat, these could be different for each individual car. Lastly, we talked about functionalities of this car like drive, switch headlights, and we also touched on private methods, in this case commentate, which described when we would drive a certain amount of miles. In this video, we want to build on top of that. So let's say we want to design a gas car and also an electric car class. How would we go about this? As you know, there are a lot of similarities between these two types of cars, but also there are some differences. Let's go over these similarities and differences one by one. So they both have top speed, maybe they're different. They both have odometers, which are the same. They both have headlights, which are also the same. One has MPG, but electrical has MPGE, which is a little different. And then gas car has fuel, but electric car uses battery, which is quite different. They both have color, they both have interior material, and assume that they both have the same type offerings, so leather and fabric. And then for the drive method, they both drive, obviously, and you can switch the headlights on and off in both cars, so they're the same. And for the commentate method, we're going to use the same method for both of them. But then when the gas car drives, it uses fuel. When the electric car drives, it uses battery. And lastly, let's assume that we can also update the software of the electric car. So it's one of these newer cars that comes with over-the-air software updates. And it has an autopilot or self-driving option. So what we went over here is basically our first option on how to design these two classes. But as you can tell, we are repeating a lot of things on both sides, which means we are wasting a lot of time copy pasting things, and when we need to change something, we have to change them on both sides. So is there a better way to go about this? So option 2 is to combine everything. So put everything in a single class called car class and just add them to each other. And we define a type where type can be electric or it can be gas car. And based on that, we decide which methods to use or how we go about assigning attributes and things like that. So we need some if-else mechanism that would check the type. And if the type is electric, it would do a certain thing. And if the type is gas, it would do something else. This would make the logic look something like this. As you can tell, this can become cumbersome quite fast. And let's say if we have a new type of car added, then we would have to change this logic everywhere in our code. So is there a better way to go about this? A good solution to this problem is to use inheritance. What is inheritance? It really is what the name suggests. So we define a parent, in this case the car class, and then we define some children, which are classes that inherit from that parent class. What does inheriting mean? It means that they take the attributes or the characteristics of their parent class. So we would take everything that is common to both types of cars and put them in the parent car class. And then everything that is different we'll leave for the specific electric car or gas car classes. So the parent car class has all the common items like odometer, headlights, color, interior, drive, switch headlights, and the commentate method. And I'm also leaving out the items that really don't help explaining inheritance for this video. So let's take a look at electric car. So as you can tell, this is a lot shorter and cleaner than what we saw a little bit ago. So we only are adding the MPGE and battery as parts of the electric car class. And also we're defining that, this car can have a self-driving option. And that's it. You already have the electric car class. The gas car looks even simpler than that. So you only have MPG and fuel, which are not part of the car class already. So that's it. You already have your gas car, you have your electric car, and they both inherit from car. Okay, now let's add the methods that we talked about. Also, let's assume that you have two different teams. One team is working on the electric car class, one team on the gas car. One advantage of using inheritance is that there are no dependencies between these two classes. So let's say team 1 moves forward and starts implementing the drive method, the update software, and also reduce battery methods. Now your electric car class is completed, and team 1 did not have to wait for team 2. And then later on, when team 2 gets to that point where they want to implement their methods, they can go ahead and not worry about what team 1 did, because again, they're both just inheriting from the parent car class. When you're working on a larger code base with a bigger team, this is extremely beneficial because it means a lot less code conflicts, and also you are able to plan things a lot more easily because different pieces of code become more modular. Okay, let's code all of this up. Before we start, I just wanted to show you how my folder setup is. So I have 3 files called car.py, electriccar.py, and gascar.py, and each of them will contain the class with the same name. You don't necessarily have to pick the same name, but I'm doing this just to keep things very clear. Also on the screen on the left, I'm putting the car class, in the middle electric car class, and on the right gas car. I'm gonna switch to presentation mode so the font is larger and you can follow along. To use the class, we first need to import it. So when I write from car, that first car, if you notice, this is the file icon. And then from that file, I will import the car class. And if you notice, there is if I go back and, you see that C, that stands for class. So from the car.py file, I'm importing the car class. So for the normal notation, we would just do the name of the class and a colon. But if I want to inherit, I need to open parentheses and just pass the name of the class that I want to inherit from. I also need to write pass, and if you're not familiar with pass, it just means do nothing and move on. And that's it. I already have all the functionalities that the car class provided to me with only 2 lines of code. Let's go through a quick example to verify this. So if I instantiate a car using the parent car class, if you remember, we need to pass color and interior material. Now if I call the drive method, let's say with 10 miles, I see, red car drove 10 miles. Now, if I change this to electric car instead, I expect to see the same thing because we are inheriting, all the functionality. So everything is the same at this moment. So one thing to realize is that we are calling the parent constructor method because there are no constructor methods on electric car currently. Let's add the attributes specific to electric car. So I have MPGE and battery is 100% full in the beginning. Now, if I try to instantiate an electric car from this class, I expect to have all the functionalities of car plus these 2 attributes that I just added. So let's print out battery, for example. I expect to, you see I have battery and MPG in addition to everything. So I have 100. Now if I change this to car class, now I expect to see an error because car shouldn't have battery, but accessing color should be fine. Okay, let's clear all of this up. Now we're ready to write our own constructor. So let's say this car has the same attributes like color and interior, but it also has a autopilot option that people can either order or not order. So we're gonna leave that to be a boolean. I can instantiate an electric car using this constructor and print attributes from it, and this works just fine, but we want to use the drive principle as much as possible when we are coding. So let me show you how we could go about that.
What are you doing?
I'm keeping my code dry.
That's not...
As you can tell, these 2 lines are the same as these 2 lines. So instead of rewriting the code, I can just call the parent's constructor method and pass the self keyword as well as the parameters to it. And then, I can only have the additional autopilot attribute defined here. Also, if I just try to print something else like color to just make sure everything is okay, I get black and it's fine. I'm going to comment this out to show you a third way of going about this, which is the keyword super. With super, you can reach the parent class, and in this case you don't have to pass the self keyword anymore because Python already knows what you're trying to do. The difference is that here you're implicitly reaching the parent class and you're naming it. So if you had multiple classes you were inheriting from, then you would not use super. Let's just print out interior to just make sure everything is okay. Yeah, we get leather. So this is the equivalent of naming the parent class and inherit from it. Okay, let's clear super out and let's just define a very simple method. And I'm gonna go a little faster because you're already familiar with this. Let's say we can update the software version of our car, and it has a version that starts with 0.1, and when we give it a new version, we're gonna print out that it's updated into that version, and then we'll actually change the attribute to match the new version. So this is no different than a normal class that you would write. So just the fact that we have inherited from another class doesn't mean that we can't add functionalities to it. So this update software, yeah, so it's updating to version 0.2, and this method now only exists on the electric car class. It doesn't exist on the parent car class. Now the drive method is a little trickier because we already have a drive method on the parent class. Let's just print something out here just to test out what method is being called. Now if I call the drive method, as you see, I'm clearly calling this method. If I clear it out and call drive method again, I get an error because I'm not passing the distance argument because the parent drive method is being called right now. So if I pass the argument, I get the printout that we expect, that we wrote using the commented method in the previous video. Now, if I want to define my own drive method in the electric car class, my first option, of course, is to just copy paste everything that I had from the car class and just add anything extra that I need in the electric car, which we said we want to reduce some battery every time that we drive. Let's say we're gonna reduce half of the distance that we drive. So let's say if I drive a mile, I'm reducing 0.5%. If I drive 200 miles, the battery goes to 0. And minus equals is the same as saying self battery equals self battery minus that value. So what do you think will happen if I try to run this? Let's try it out. So I'm getting this error because I'm trying to reach this commentate method. And if you remember, we said 2 underscores make a method private. So this commentate is trying to call its parent commentate method, which is private to that class. We have a couple of ways to address this. One is to use protected methods, which is the convention to use 1 underscore, and that way the subclasses can still call that method. But that's more of a convention, so I'm going to show you another way. If you notice, this is the only line that is different. So if I just put that line up, and all these 3 lines are exactly the same as what we had. So I will replace those 3 lines by just reaching the parent class and calling drive method, which is a public method. So then I don't care what is happening beyond that. So car is just taking care of the rest of it for me behind the scenes. So if you notice, this is running fine, no errors, and my lines of code are shortened to just 2 lines. And also if I print out how much battery is used, because I've driven 10 miles, I expect to see 95. Let's talk about what we just did real quick. So we wanted to add functionalities to the drive method, which already existed on the parent class. But we wanted to add 1 line to it and still benefit from all the functionalities of the parent class. The fact that we could just call the same name is called method overriding. So we overrode the parent drive method and replaced it with a new method. This is a sample of a concept called polymorphism in object-oriented programming. Polymorphism in simple terms means when an object can take multiple forms. For instance, in our case, the drive method would take the form of the electric car version of drive if we have it, and if we don't have it, it would take the form of its parent drive method. Okay, let's write the gas car, and I'm going to go a little faster because you're already familiar with what we are doing here. So I'm inheriting from the parent car class, and I'm just adding MPG and fuel. So let's say we have 10 gallons to start with the gas car. Now, I already am happy with the constructor method that car has, so I'm not going to write another constructor for gas car. And I'll just directly write the drive method. So I want to do the same thing as electric car, except that I want to reduce fuel instead of battery. and I'm just gonna reduce it based on the MPG. After that, I can just call the parent drive method, and yeah, and I guess we don't really need that return at the end, so I'm just gonna remove it from car. Okay, that's it. Now if I instantiate a gas car, and let's say I just drive 100 miles, let's print this out. So red car drove 100 miles, that looks good. And if I print out the odometer, I should see 100. And for fuel, let's see what that comes out to. Well, let's try a different number so we get a round number. So if I do 30, yeah, that looks better. So I'm driving 30 miles and I have lost 1 gallon of gas. For this last part, to just show you how multi-inheritance works, imagine that we are to design a hybrid car class. And you know that hybrid car is not exactly the same as putting an electric car and a gas car together, but there are some similarities. So on the left, I have electric car class. In the middle, I have the gas car. And on the right, it's a new file called hybridcar.py, where I'm going to write the hybrid car class. So first I need to import the electric car and the gas car classes, and then I can create the hybrid car and inherit from both of these. Remember that order matters. So this is very powerful. So we already have all the functionalities in the gas car and electric car just by writing these 2 lines. Now let's talk about the order that methods and attributes are resolved. So there is a method called help in Python. And if I print this out, yeah, let me move this to the side so you can see this. So help shows you basically a lot of information about that object that you have. So on the top, if you see, we have the classes that we are inheriting from, and then I have the constructor for a hybrid car. So you see you have color, interior, and autopilot. And then let's take a look at method resolution order. So Python first is looking at the hybrid class, then the parent electric car, and then parent gas car. And then finally parent car, and then this thing called Python object. Everything in Python is an object, and everything inherits from this object. But pay attention to the order. And then we have more information on the methods as well as the attributes that belong to this hybrid car class that we just created. So this hybrid car that we created inherits everything from electric car and gas car, and for the most part nothing collides. But for example, for the case of the drive method, we have 2 options, and as we discussed in the method resolution order, we said that the drive in electric car is going to be resolved first because that is coming before gas car. It would be a good exercise if you try to do method overriding and write a drive method for hybrid car and basically tweak it to achieve what you think a hybrid car's drive method should look like. In this video, you learned about inheritance and method overriding. We also talked about method resolution order and polymorphism. Throughout this video series, you have learned about encapsulation, inheritance, polymorphism, and in the next video, we'll cover the last pillar of the 4 main principles of object-oriented programming, which is abstraction. As always, if you have any suggestions on the topics that you would like me to cover, please leave a comment down below, and don't forget to like and subscribe. See you soon.